In this video, we are solving two problems involving the differential equations given the initial conditions. So for example, the first one here, you are given y prime equal x squared plus x minus 3, and you are also given the initial conditions where y equal 11 when x equals 0. Now solving the equation means you are looking for the value of y or the expression for y. Now we are given the derivative of y, so in order to take away the derivative, you are going to take the integral on both sides. If you take the integral, you get back, you undo the derivative and you get back to the original y functions. So now we take the integral on the left side, which give me back the y, and then I also continue to take the integral on my right side. And this is easy, where you can apply the power rule. I add 1 to the exponent, that becomes 3, and then I divide by 3. And then this is the first power, so I add 1 to that, I divide by 2, and then minus 3 becomes minus 3x. And don't forget your constant c. So now your equation, your y expression is what? Is just this term here that we just found on the right hand side. However, we need to figure out what is the value of a constant c, and this is now where we should apply the initial conditions. So my y equal 11 when my x is equal to 0, so anywhere I see x, that becomes 0. So x squared, 0 squared minus 3x minus 3 times 0 plus c, and you can see that all the 0 they cancel out, and I'll get back what? 11 equals c, or the c value is 11, and now I can complete my equation. Y equal x3 over 3 plus x squared over 2 minus 3x plus c, and c now is 11. And that is my final answer. Okay, let's try another problem again. This next problem is also solving for the differential equation given the initial condition, plus 8x where y equal 4 when x equal 1. Now again, you are solving for y, so in order to get rid of the derivative, you're gonna take the integral on both sides. If you take the integral, you will undo the derivative, or you get back y. And then now on the right hand side, you can take the integral using again the power rule. So I add 1 to the exponent, and then I divide by that whole expression. And then the same thing here, I add 1 to x for the exponent, and then I divide by that. And then don't forget to add the constant c at the end. 2 over 3 plus 1, that will give me 5 over 3. So I have 5 over 3. The same thing at the bottom, 5 over 3 plus a divided by 2, that is 4x squared plus c. And then dividing by a fraction, you can flip that upside down for 3/5, and then you still get x to the 5 over 3 power plus 4x squared plus c. Now the last thing you need to do is you have to figure out what is the value of c, and we know that when x equal 1, your y equal 4, that is your initial value. So my y equal 4 when my x value here is equal to 1 right here. And then again, I see x, I plug in 1, and you see that 1 to the power of anything is 1, right? So you have 3 over 5 times 1, and then again 1 squared is 1, and you can see that multiplied by 1 is just same thing. So I have 4 equal 3/5 plus 4 plus c. Now I see that I can minus 4 on both sides, so I have 0 equal 3 over 5 plus c, and then my c I move 3/5 to the other side, so minus 3 over 5, and therefore now I can complete my equation y equal 3/5 x 5 over 3 plus 4x squared. My c I just found it here to be in a minus 3 over 5, and that is my complete solution to the value of the y.